Hey everybody, this is Mr. Chernetsky, and this is Lesson 6, Partitions. So a partition is just a way you can think of it as a division. So it's a way we're going to divide a line up, or a line segment, I should say. So we're going to start out simple. We're going to start out with one-dimensional horizontal lines and vertical line segments, and we're going to partition them into fractions, and then we'll get to 2 dimensions on a coordinate grid from there. So let's start out with something really simple here. I want a partition, or a point that divides the following segment 1/4 of the way from A to B. Well, the way that I would approach this is, what's my distance from A to B? Well, my distance is 4 units. That's from 0 to 4. That's pretty easy. So 1/4 of the way, this is pretty easy. I'm actually already divided into quarters because each unit is, well, it's 4 units long, and we're already divided into 1 unit. So 1/4 of the way would be, well, this would be 1/4 of the way. This would be 2/4 of the way. That would be 3/4 away, so the one we're looking for is right here at 1. And that's our coordinate. That's the point that's 1/4 of the way from going from A to B, so from left to right. Well, what if we take those same 2 points? I want to go 3/4 of the way, but this time I'm going from B to A. So this time I'm starting at B, starting at the right, going to the left. Well, same sort of thing. My distance is 4 units. And if my distance is the same as my fraction, well, that means it's pretty easy. We're already divided into fourths here. So this would be, at 3 would be 1/4, 2 would be 2/4, and 1 would be 3/4. So going from right to left, 3/4 would be at the same spot as question number 1. So that's 3/4 of the way from B to A. Okay, moving on. Number 3, I want to go 1/4 of the way from A to B. Well, from A to B, this time, from 0 to 8, that's 8 units, my distance. So that means I'm not divided into fourths anymore. Okay, I gotta look at my fraction and figure out how far is 1/4, or each division, each quarter, I would say. So the way that we do that is we take our distance and we divide by the fraction. So 8 divided into fourths is 2. That tells me that each partition should be 2 units. So if I go 2 units from A, that's 1 partition, that's 2, and that's 3. So now I've divided my segment into fourths. So this would be 1/4, that'd be 2/4, that'd be 3/4. And what I'm looking for going from A to B is my 1/4. So 2 would be the point, 1/4 of the way from A to B. Continuing on. From B to A. So starting at B, going towards A. Our distance is 10 units from 0 to 10, and we want to divide that into fifths. So if I take 10 divided by 5, well, that equals 2 again. So if I start dividing that, going every 2 units, and then starting this time from B, going left, 1/5 would be at 8, 2/5 would be at 6, 3/5 would be at 4, 4/5 would be at 2. So I'm looking at 2/5 of the way. Oops. Point I want is 6. 6 would be my answer. Okay. All right. Keep going here. Going from -5 to +5. Again, that's 10 units. It's 5 units to 0, and it's another 5 units to 5. So that's 10 units. Again, we're dividing it into fifths, so 10 divided by 5 is 2, so we're going to partition every 2 units, going from A to B. So this would be 1/5, that would be 2/5, 3/5 at 1, 4/5 at 3, so the answer we're looking for is 3/5, and so our correct answer would be at point 1. Okay. 5/6 of the way from B to A, so our distance from -2 to +10. Well, it's 2 units to get to 0, and then it's another 10 units, so that's got to be 12 total. We went 5/6 the way, so our fraction we're dividing into 6. Well, 12 divided by 6 equals 2, so again we're dividing into 2's. We're going from B to A, so we'll start from B, go left, so that's 1 partition. And we'll just divide it every 2 units. That'll get us into 6. So at 8, that's 1/6. That's 2/6. That's 3/6. 4/6 of the way. And 5/6, which is what we're looking for at 0. Okay. Moving on. 2/7 of the way from A to B. Well, from -9 to -2, that's exactly 7 units. So the nice thing about that is we are already partitioned. So we don't have to divide everything. Every unit is its own partition because, well, 7 by 7 is 1. So going from A to B, that's 1/7. That's 2/7, 3/7, 4/7, 5/7, 6/7, and if I actually got to B, it would be 7/7. But the one we're looking for is 2/7, or -7 would be our answer. Okay. Alright, 2/3 of the way from A to B. Our total distance, let's see, it's 5 units to 0, from -5 to 0, and another 4 units, so that's a total distance of 9. And we want to divide that into thirds. Well, 9 divided by 3 equals 3, so that means we're going to divide our partitions every 3 units. Okay. So 1/3 of the way would be at -2, and 2/3 of the way, going from A to B, would be at 1. So that's our answer. It would be 1. Alright, we're going to do the same thing, but we are going to do on vertical lines. Okay. So the first one, from A to B, from -10 to +10, that is a total distance of 20. Okay, because it takes 10 units to get to 0, and another 10 units to get to 10. to get to 10. Well, 20 divided by 5 equals 4. So that means we're going to partition every 4 units. So 1, 2, 3, 4. That's one partition. 1, 2, 3, 4. That's another one. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So going from A to B, that's 1/4, 2/4, or sorry, fifths. That's 1/5, 2/5, 3/5, and 4/5. So we went 3/5 of the way. So that's that answer right there. So it would be at point. So it'd be we'd put our point at 2. Number 10. If we want to go 1/3 of the way from B to A, so we're going down. Well, from +8 to -10, that is a total distance of 18. Dividing that into thirds, well, 18 divided by 3 equals 6. So every 6 units, starting at B going down, 1, 2, 3, 4, 5, 6. That's one partition. 1, 2, 3, 4, 5, 6. There's our other partition. So this would be 1/3, and that would be 2/3. So we're looking for 1/3 of the way. So our point would go at +2. Okay. This one's a little bit trickier. So we're dividing into thirds. Our total distance from -3 to +3 is 6. 6 divided by 3 equals 2. So if I divide that into, partition that into 2. So going from A to B, we want to go 4/3 away. That's a little bit different. Okay. Well, there's 1/3. There's 2/3. We actually have to keep going in order to get to 4/3. So if we go up to 3, that's 3/3. And if we go past that length here, that would be 4/3. So our point would actually go outside A and B, and it would be at +5. Okay. Same thing for number 12. So our total distance from -6 to +2, that's 8. And divide that into 4, so 8 divided by 4 is 2. So going from B to A, so starting up here, every 2, that's 1 partition. There's another one. There's a third. So this is 1/4, 2/4, 3/4. At 6, that would be 4/4. We want to keep going all the way down here to 5/4. So our point would actually be at -8. That would be our answer. Okay. So we've done horizontal and vertical, but one-dimensional line segments. Let's see if we can extend that to a two-dimensional line segment. So I want to find a point that divides the segment 3/5 away from A to B. I've already plotted those coordinates at 0, 0, and 5, 10. I can actually redraw that line here and try and draw it as straight as possible. Okay, so there's my line, and I want to divide it 3/5 of the way. Well, the trick that I'm going to use is I want to actually break this into the horizontal and vertical components. So let's take our horizontal components first. So our horizontal components, our x is going from 0 to 5. So if I put a point here on the x-axis, here's our horizontal component. Okay. Now what we're going to do is we are actually going to do what we just did. We're going to find a point 3/5 of the way on this segment. Well, that's pretty easy. We have a total length of 5. That means that our units are actually divided, our segments are actually divided into fifths already. So going from A to B, 3/5 of the way would be right here. 3. And that's actually the x-coordinate of our answer. So we're actually halfway done. And we're going to do the same thing with our vertical. Okay, so our vertical goes from 0 to 10. So here's our vertical displacement. We'll put a point at 10. There we go. And we want to find what is 3/5 of the way on the blue line here. Well, our total distance, that's 10. We're dividing it into fifths, so I take 10 divided by 5 equals 2. So every 2 segments, starting at A, going up, there's 1 partition, 2 partitions, 3, 4, okay. So that's 1/5, and that's 2/5, that's 3/5, that's 4/5, and what we're looking for is the 3/5. So 6 is our y-coordinate. So we actually have the answer right here, and we're going to plot this and verify that it's on our line and it's right where it should be, kind of by lining this up. So if we line up our y-coordinate and our x-coordinate, we see we end up right here at 3/6. That is the point that we're looking for. That is our answer to question 13. Okay. We'll do another example. Let's find a point 1/3 of the way from -3, 2. Let's go ahead and plot our points. There's A, and 3, 8. There's B. Try and draw this as nice as possible. There we go. Alright, so we need to do the same thing. We need to break it into our horizontal and vertical components. So let's look on the X. We are going from -3 to +3. So we're going to ignore everything up here. Just look at our red line segment. Okay. We're dividing it into thirds. We have a total distance of 6. Well, 6 divided by 3 equals 2. So I'm going to divide that going every 2 segments. So there's 1 partition, there's another. So -1 would be 1/3. +1 would be 2/3. Well, we're looking for 1/3. So our x-coordinate of our answer is going to be -1. Halfway there. Let's do the same thing with our y's. Well, our y's go from +2 to +8. So looking at our y-axis here, we go from +2 to +8. Again, that is a distance. Let me do this over here. That's a distance of 6 units. We're dividing that into thirds, so 6 divided by 3 equals 2. So we're going to divide that partition that every 2 units. So starting at the bottom, going up, because we're going from A to B. There's 1. There's 2. So this would be 1/3. This would be 2/3, but we're looking for the 1/3 of the way. So our y-coordinate is 4. Now we can check and see by lining that up on our line segment. There's our point at -1, 4. That's our answer. Okay. Checks out. And that's the answer. I also have a GeoGebra program that will assist you in doing this. If you prefer to use that, you can also just use this method, whichever works for you, the pencil paper method or using the GeoGebra to help you out. So we'll take a look at that in the next video.